Welcome everyone for Cloud Computing and Big Data, our practical lecture 3.1. It's about building scalable machine learning pipelines with Apache Spark, and it's really a practical lecture, so we will demo a little bit about HD Insight and how you can use Apache Spark in one of the big cloud vendors, which would be the Microsoft Azure cloud. But in previous lectures, you have also seen that basically the same environments on these open source tool sets like Apache Spark, Apache Hadoop, and many of those are also available in AWS services, Amazon Web Services, or of course also in the Google environment called basically Dataproc and so on. We will come to this throughout the lectures. And as I said also early in the course, this is sort of a little bit injected in the course early here, this practical ideas, to give you already early assignment 1, so that not everything is, basically coming at the middle of the course or at the end of the course, so that you can start with assignment 1 right away. But before we look into the material of basically practical lecture 3.1, which complements in a way lecture 3 and lecture 2, where we also will dive much more in machine learning fundamentals today, let us review what we had the last time. And the last time was really thinking about Apache Spark, basically as an open source toolkit that should be now known by you. And we looked at several different pieces of this interesting software stack. And one of it was, of course, the strong library support, right? There was Apache Core that we discussed, the Apache Spark Core, which is sort of this, which enables us to have this master worker paradigm, if you remember also from the video, right, where you have 1 or 2 head nodes giving you a Spark context and interacting heavily then with a cluster manager, which in turn is then responsible to distribute the work and tasks actually across different worker nodes. And the worker nodes are then where the scalability comes from, which is this picture in a way, right? Throughout the course, you will see that again and again. The idea is, of course, that we can do it maybe on a small box if you want, but if you have a high big data workload, we can extend the number of worker nodes very easily. And I show this a little bit today, also how that works. So this core is loaded. It has not only distributed computing, and in this sense, also, if you have seen the DAX here, that is directed acyclic graphs based on the RDD objects, you have also this parallelization. So depending on the dependencies on the DAC, you also can say, basically some of these things might be executed in parallel. So you would have a distributed and parallel environment. And you noted the notion of scalable. Scalable comes then also from, I think someone needs to mute shortly. Sorry. Sorry for that. But then essentially you have the idea that some of the things can be really scalable in this. So if you need more, data analysis, you can easily extend the number of worker nodes. In this sense, the scheduler is responsible for this, enabling us really lots of interesting functionalities in parallel and scalable. But the 2 cents to take away really was, you program all very much not aware of all of these parallelization schemes and the distribution, right? So in this sense, the executors will take care of everything. They are located somewhere that you don't even know. And this is an important consideration. Just have to think here. I think, Daniel, if you can, I can mute you. Sorry for that. So basically, this enables us now to think about very much in parallel and scalable using distributed computing power. And you as a programmer, let's say a machine learning specialist, is then actually having the idea of basically doing this without any idea that this is all parallel. Again, everyone who is joining, remember to really mute yourself, right? That would be important for the video. Thank you very much. Yeah, and this core is then the kind of spark really for much more functionality. And this is quite interesting because Apache Hadoop was there in the past, a very powerful tool, but you have lots of different open source tools working with it and not really leveraging memory, which was the other idea of Apache Spark, if you remember, right? So hence you have a certain functionality within Spark, which enables us already to not only use memory and caches very nicely, which, enables speed, but it also gives you lots of different functionality that is often in data analysis problems. And one of us, of course, the structured query language here, SQL. You will see when you come to the work after you're studying, lots of data is still stored, of course, today in the structured, query language oriented relational databases, as they are called, right? Some of them are even object databases these days. But still, the key message to take away is that you can have SQL statements to extract data. And actually, in one way, we also do this today in a demo, but not really on steroids, rather on a data frame and so on and so on. Spark streaming we discussed last time, when, of course, you maybe don't want to really keep track of all what's happening, let's say in a Twitter stream every single day, but you want to understand, is my product known, right? Or is some tweet maybe talk about my product, so you can filter on very specific words. And this is also quite nicely parallelizable, and you can leverage then the scalability of the Apache Spark cluster as well. Just have to go again. I think while more and more people come, I need to mute here some. Okay, just again, please try to get muted on Zoom. So then, of course, you already know a little bit about the machine learning library. That's what we had already. We discussed a little bit the logistic regression, which follows a loss function and then gives out a probability between 0 and 1 here, using the logistic function, really squashing this regression, which means real valued output, into a certain class of probability of saying it's more closer towards 0 or it's more closer towards 1. Hence, it's class 1 or class 0. And this is common in machine learning problems, that we talk about probabilities instead of very clear classes in a sense. Only that, of course, many users will at the end just really realize that this is class 0 and 1. But internally, mathematically, we rather, let's say, as this graph a little bit suggests, move towards one class or so with probabilities, and let be here with 0.8 or so in terms of probability that this is probably class 1. And if you dive into machine learning fundamentals, like we will do today, and of course more theoretically, you will see that learning is actually probabilistic. So it's called probabilistic learning theory in short, and many of these assumptions are really based on that. But this is something for a machine learning course and not really for us to go into much more detail. Finally, we discussed a bit the graph idea of an application. You can imagine social media today, also especially, for instance, Facebook, but also YouTube and others. They are really a big web of interactions, of pointing to different ones. And there we had the PageRank example the last time of showing a little bit why iterations are kind of a key element. And if you have iterations, of course, you benefit from having data in the cache again and again, because you use the data again and again. And this gives us also the opportunity then from the second part of the last lecture to understand this iterative learning and the benefits that then Spark provides. Because Hadoop was there before, interesting framework, also distributed, but in one respect, it was really not optimized for memory, what Spark was. And if you have problems like here, logistic regression, right, to knock down the error by going down an error surface using, for instance, here stochastic gradient descent, you basically can show that you use the data again and again and again. And with this, of course, the cache effect, the speed up you have from memory and caches is significant. We have also learned, of course, you have to go there and pay the price for it, right? So this is something, of course, which stays with the whole course. I will make another notion today on this in the practical lecture. When we review now, of course, memory intensive cores, they are expensive, right? So hence, if you really want to leverage Spark, if you really benefit from the speed up, you have to pay for quite some significant resources, because those, as you remember maybe from the last lecture, those resources which have less memory are, in the 0.00 euro region. So almost nothing. Today we will learn then, when we create a cluster, it's around 4 euros, per hour. So it will accumulate in cost, especially if you think about you in SME, you do this 24/7, you do this over a year. I think you can do the simple math, right? 4 euros times 24 times 31 or 30 for a month, etc., etc., and then times 12 for a year, whatever. So you have to incorporate this all in your price schemes. The beauty, however, is, and this is an important statement, you don't have to configure all of this. I mean, you will see today in our practical lecture, and we will start very soon, that it's extremely convenient to have an HD Insight cluster with Spark created. And this gives away, you know, the troubles you have from Spark version 2 versus Spark version 3. Then you have the storage interaction. Then you have this different ideas of the underlying environments, connecting it potentially also with security. You want to secure, you know, your solution. And we will see in this today that it's quite interesting to use that. And hence it is worth in a way to pay the price, because if you want to do it yourself, you not only have to buy the hardware, which is of course one big thing, to install Spark and let's say all its different libraries on top then, and or that maybe, you know, will be used in collaboration with Apache Hive, for instance, we have seen, or Presto and others. This is quite something. Right, so but let us go basically now to think about another machine learning problem. And we have learned basically machine learning with logistic regression already from sort of some perspective. And today I will again go into several different aspects of it. We also will review the true positives and true negatives and so on as a part of another application domain problem. Hence, this is a really additional practical lecture. You will see I don't do any YouTube videos here as a reference, because in a way we will do here very practical things. It will be lots of hoppings between slides and real software. That's sort of in just normal. But we will have a small cloud demo really starting then of understanding more this machine learning process. Also in combination, of course, with a crisp DM. I also basically this process diagram I already introduced, so that basically after this, you should have a better view from machine learning as a process, but also what you have available and what you basically have to have as given, and lots of elements. Then, of course, we want to have a real application example. It's a practical lecture, so we go to HD Insight and we'll load one of the application examples that is available there. So that's a benefit for us. HD Insight comes with a nice sort of tutorial, and we will make use of it also in our assignment 1. Here and there, we'll do some small mathematical building blocks that should not afraid you. It's basically just to give some foundational machine learning elements in. And then again, the idea is to think about in the whole crisp DM, where we go through, combined with the machine learning process that we will formalize a bit, that you get the understanding that machine learning is much more than just throwing an algorithm at it, right? It means lots of work in data feature generation, data understanding, data exploration. Working with data is a key element of it. And then understanding data, understanding what model I can use with the data is then the key essence basically you have to do over time. And of course, we start again, you know, basically from our initial insights we had from, you know, lecture 2, so you don't have to be a machine learning specialist. In the second part, we will continue to use the Apache Spark pipelines. And this word is very important in industry in a way. So this is something where you have one formalized process of how you, let's say, massage the data, perform feature engineering. We will see that today, but also look at the data, transform the data, and then you want to do and train all of this to have a model. But in order to massage all the data again, or putting it through the pipeline to do all the, let's say, data preparation work, you want to have that fixed. So that when you do inference, when you want to use the model on a daily basis, really in your product, you don't want to do any of this again and again and again, right? Hence the idea is with these pipelines to automate a bit all of these processes that are needed, cut away the training versus using maybe, for instance, inference with a test set. And we talk about this in the second part a lot. Throughout the lecture, of course, we use the PySpark, Apache Spark kernel, and I will talk to you what that means and also the different versions and so on. And we'll make the connection then also to some evaluation that you have available. We learned in lecture 2, there are many evaluation options and results visualizations. Today, we focus a little bit here on the, as I said, true positive and, you know, true negative, etc., confusion matrix of sort. So a sort of very rich practical lecture that is directly relevant for your assignment 1. That's why we put it here today. So hence, when we do the data exploration, we have cloud demo in the first part now. Always remember, we do this with supervised learning, right? So the idea is here to have labels. And if we now come back to our stepwise process that you by now, of course, have understood, I hope, because we have done this now after a couple of lectures. We have always the idea of needing a subscription in the cloud. We have pay-per-use today. I will show you what that means in a moment. So let's go to more practical setups. So we have here Microsoft Azure. I'm actually logged in here using my, basically login from the university. And the first thing you have to think about, you log into Azure, and that's also what you should do in your assignment. You see the description. You basically go to, if you're really a user like me, to subscriptions, right? That's where the money comes from, right? So we have here a pay as you go. In other words, swipe the credit card idea, right? So of course, this is something where quickly you can come into costs. Hence, you have a student subscription where you get automatically $100, I think. And then you can play with the system, but it's very limited for students. Hence, the idea of using HD Insight cluster was removed several years ago because it's in a way a very costly cluster. And I bought this here, and we have teaching funds available for this, so don't worry about this, so that you get access to it. But just for the understanding, it's good for you to know that many of the cloud systems, and this is true for AWS and others as well, you need to have a sort of subscription somewhere where you put your credit card, and then, it's active. So we have a very specific subscription ID here. You see also I used that already with a storage account in a cluster. And what cluster, hence, that would be the HD Insight cluster, right? So that means I use these top products. You can imagine a cluster without storage doesn't make sense. So you see already here that basically the costs, we will see that also throughout our lectures together, will accumulate. We just started the course, so there's not a month and not many hours gone. So then the costs will be actually here updated. So hence, for Microsoft Azure, coming back to the slides, just that you connect a little bit to the practical experience, you need to think about a subscription. In your particular assignment, I will give you access to the number 2, right? This kind of Spark cluster in HD Insight. You will get access automatically. I pay that, I organize that, and you can use it. And using, of course, university funds. But in a real life scenario, if you are in a company, that's your job, right? You have to convince your bosses of saying, well, we need a subscription. We don't get that for free. And we need the company credit cards for it. And in some cases, even as SMEs, it makes sense to contact them. They're, let's say, sometimes really, really nice offerings for SMEs to, as I said in earlier courses, hook them a little bit. You get like, I think 10,000 credits, for instance, or so for free when you use this, all the different services and so on. So there are quite some nice starting, let's say, budgets that are given away to SRE. But of course, think about at some point in time when you have it incorporated in products, it is not anymore there. And then you suddenly start, let's say, like here, for instance, in the example of Apache Spark with $4 every hour or €4 every hour. And in a way that doesn't sound much, but again, do the math very quickly, 24/7 it's running. And even the funny part is, and I will come to this again throughout this lecture today, if the Spark cluster is running, you are using the resources. Hence, the money is accumulating. Even if no one from your company or no one from your team is using it, you still pay. The Spark cluster is sitting there running, waiting for you for inputs. Right? And if you don't use machine learning or any other application with it, it is idle, but it's not the problem of the cloud, it's still used. Hence, this pay-per-use, as the name suggests, has to be carefully evaluated if you go to the cloud. Right, but we will do the point then later. And of course, then from step 4 or 3 to the next ones, it's quite of the same thing we did already in lecture 2 in a way. We have a Jupyter notebook using a PySpark kernel, create a Spark session with this, and then, want to analyze the data set, do some data inspection, exploration of the data, maybe some visualization, understanding like we had in the Iris Setosa and Iris Visonica. Visualization was quite interesting to understand. And then we did a performance, basically perform a machine learning model on it, on a performance cluster, which was essentially Google Colab and not really a parallel big scalable cloud. Right? It was still better maybe than my own laptop, because if you have the Pro version, you can even get quite good cutting edge TPUs, tensor processing units, or GPUs. And then you do the machine learning model evaluation and refinement. So this is sort of the specialized approach. And we want to use this approach again today in practice. Before you do this, there are some obstacles. And the obstacles in one respect are also a protection. because if some people in the company don't really know what they're doing, you can have increasingly much costs. And I think here the idea of resource providers in one respect, before you even create the HD Insight cluster, right, is that you will notice very quickly that your subscription is actually not registered to do HD Insight. Hence, basically, you have to do a certain step first of registering so-called resource providers here, basically in the MS Azure cloud. So I want to demonstrate this a bit more lively because, we have this idea of quotas. And this is an important thing, or basically even more before this, sorry for this, it's the idea of having our subscription. And then in these subscriptions, you will come to the idea of, what you have there. There are certain resource providers. And when you start with this, you have everything is 0, right? There's no registration, registration required. Some of them are already kind of prepared for you and registered, but many of them are not. And hence I had to first say, well, we are actually users of HD Insight, so let's register. And the same is actually true for storage, because you can imagine a cluster without any storage doesn't make sense. I use here the Microsoft storage, the different options available, but also this needs to be registered. And once you have done this, then you can proceed basically to really create an HD Insight cluster from the sort of perspective of the resource providers. But you can imagine, once it takes just a couple of minutes to get registered, so that's not really a big issue. But, and this is the next step, you have quotas as well. And hence the quotas again are a protection mechanism of saying, if some of your people inside the company suddenly create, let's say, 100 worker nodes. We don't know really how Apache Spark works. You can imagine here a little bit the illustration we had already from the last time. We had 4 worker nodes and 2 head nodes, a couple of zookeepers here for free, that's fine. In the end, €4. If I now know nothing about this, and funny enough, of course, if you create a HD Insight cluster, the costs will be, a little bit, let's say, not always so visible if it's running and so on. So if you do 100 or 200 of the workers, you can quickly see how your costs will be per hour quickly, accumulating and increasing. Hence, the ideas of quotas here is to say to limit this. Hence, when you want to start, you would see when we, for instance, pick a region, and this is an important part as well of the demo here. When you have the quotas, of course, you have to think about that the cloud has different regions and also different services. So we focus a little bit on HD Insight here today. And, then, of course, the idea is that within your specific region, you basically want to use your kind of specific idea of the services, or let's say resource type required. We come to this also in a moment, right? There's all sorts of different names, and you see I already use some really for 100%. And the reason is because I have my cluster already running for you, right? If I would start it up, it would take like 10 minutes, too long for the recording. And you see also some regional CPUs I didn't really use yet, but in central US, we actually exhausted our quota already. It was 48 essentially types of resources of the standard EPAL3 family. And this gives us also an opportunity to think about, okay, we can always request more, but of course, this should be a little bit regulated by someone in your company that knows really how it works and the associated costs. This is sort of a protection mechanism that you don't suddenly start of creating a, Apache Spark cluster with 100 nodes or worker nodes. You can still do this, right? And this is, of course, another part of this, but then you have to calculate your costs in. Good, but having basically done this, there's a certain way of creating a cluster. I will just briefly show you this also in a live demo here. So you have the HD Insight tab. There's a cluster already running, as I was saying, that we want to use in the first part, but more node will be in the second. If you want to create one, you get certain questions. Pay as you go is your subscription. You have to create a certain resource group. I have already resource group here created. That's what you have to do to bundle some of the resources. You have to enter a name and then a certain, let's say, region, right, where the cluster is running. Think about also maybe where your data is located, like central US, for instance. And then you have to select a cluster type, and you see there are different ones. The Hadoop one I was alluding to earlier, but there's also Spark cluster, for instance, available. Kafka is more for, let's say, larger systems with having also sort of workflows. HBase is much more for databases. So you have dedicated cluster types. We create a Spark cluster here, and then you come to other questions for storage. There, the quota of the storage is now very important. If you don't have the quota, you can't create it. That's an important factor. And you can, configure lots of security, networking contexts, something we can really now tackle all of this in this course. And I don't press now review and create because it will then, create the cluster and everything. I have put everything here on the slides to really understand this. When you do the Spark cluster, you have to add a password here also for an admin user, for instance. Then you are needing to have the Spark version to be decided. Spark 2 is not anymore supported, so the most cloud vendors move to the version of Spark 3. And then you come in the last area here of configuration and pricing very quickly to this idea of how many worker nodes you want, right? That's the only field you have to steer. And you can imagine, as I said before, if someone doesn't know it really, okay, I do here 100, your estimated cost hours will go very quickly up. And think about it, that it means really by the hour, even if people are not using it. Creating it, reviewing it will give you some certain times to wait, hence the clock here. And let's say 10 to 15 minutes, usually the Apache Spark cluster is there. It depends on how many worker nodes, obviously, but still you can assume that it will be very straightforward. And from that one, that's why the warning is here, your time is ticking, right? The HG Insight cluster is running. So hence the money is counting. But having then the cluster available, like here, you see basically we have one available. So I will remove here from the idea of creating a new cluster. I go back to home and we will use, of course, the one created. Otherwise, we couldn't do that in the whole time. You see it's quite deployed and it's running as a feedback. Hence, it accumulates costs. And you have this nice different services here that you can use. And of course, the one we want to use is a Jupyter Notebook I already opened here, right? So you see basically Jupyter Notebook is one click, and then you basically come to a very nice Jupyter Notebook environment. I want to open assignment 1 because it's of course of our relevance for the lecture today and also for your assignment 1. So coming back to this, you will be given this resource group access, right? That's what I will document in the add group. And then you can do the same steps, activating the Jupyter Notebook, so you don't have to deal with the idea of how many worker nodes you have, etc., etc. That's of course what I have done for you already. You can just use it. But make sure that you use a PySpark kernel, right? When you go to the Jupyter Notebook. So again, jumping back here, different kernels are there that you can choose. So make sure you have the PySpark kernel. Good. Coming back to the real idea of applications. This is something already known to you, so I will quickly go over this. I mean, the Chicago food inspection example we already discussed, right? So it's about, predicting if we fail in food inspection. And it's coming a little bit to some formalization of the diagrams now. We would say the theoretical background or the feasibility of learning from data is really to think about that we can learn a so-called unknown target function that really would be the ideal function that we don't know, right? But something like this was creating the data. And we, in a way, want to learn this function, but it goes far beyond function approximation from statistics, for instance, right? We want to learn from data to create something. Hence, has a certain meaning. We go through data to it and then have several training examples available. So having this training example is also something we discussed before. This is a supervised learning scenario. So for all of the different kind of elements, complaints about the stores, we would have also the label of pass or fail. This is an interesting label thing because we will review today that there's not only a binary classification problem, but maybe more classes to think about. Hence, if we now formalize this a little bit, there are elements we don't know exactly, which is a target function. We never really will know what the ideal function was creating these training examples. But in sort of machine learning, we want to go to this direction. Right? We want to understand, can we approximate this F somehow? But we have only training examples. That's, of course, something what we have in terms of storage. But we have also, of course, something which needs computing, hence a course called cloud computing, which we will come to in a moment. So when we now start a little bit, and now I want to really have starting the assignment, here in the different areas here in the cloud. So we're back in MS Azure that you see here. It's remote Azure HD Insight, where we start now all the process and starting a Spark application. We import the necessary, let's say, libraries here with Python from Python Spark, and we're starting a Spark application. This will give us also the idea of what we discussed previously in the lectures, right? So we think about now that this whole machinery is starting and that we need a sort of grip to it, a grip to Spark and the cluster manager for short, right? So sort of having the head node working for us. And that is exactly what this step is doing. You see that Yarn is starting here, the cluster manager, and is then creating this Spark context and the driver program here that now we can have something to work in Python with this environment, right? Of course, Python, you can do lots of different things, but it would be all not maybe remote, or it would be all not using the cluster. Now we have something, the session available, which is then the Spark, which we so-called also have the context to really work on. We don't care in the moment about the worker nodes. It will come how that materializes very shortly. And in later lectures, we will understand also HDFS. Here, the context is in the moment now about the head node. So let's go back if that was working. You see here in the live demo, we have now a Yarn cluster manager that is ready for us of doing something. Now, I said to you, there's an example in terms of data. Hence, we have to understand that there's some data on the food inspections already existence we can look in. As you remember from the CRISP-DM process, what we also want to do is we want to inspect the data. We want to look at the data, how it looks like. And you see here a lot of different elements. Basically, so people lightning required minimum food gains. There are complaints, there's some positive effects. But of course, we have also here and there the guiding label that gives us then the kind of supervised learning to this. So when we come more to the schema of things, so when we want to look, and you already see a difference to Google Colab here, right? With the job IDs, you see here this areas, the 6 executors on 15 cores, they are doing some things in the background in parallel. And this will come more, of course, if they're more computation intensive jobs there. And when you now do this, you see the progress, the job is starting. Okay, we want to fetch based on the Spark remote environment now, basically what we have in terms of this data frame that we created here, this ID name, the result basically in the end of is it fail or pass of the inspection, but also violations, right? So what are the valid dishwashing is bad, food, and etc., etc. So the idea is, of course, to learn from this, right? To think about now in the first step, can we use this, these complaints and these violations and other features to really predict if this interesting name here of the restaurant, whatever it is, would pass or fail. And this is the idea of the machine learning that we want to review. Hence, we have now this cluster created. And I understand that this is a little bit fast here, right? So students, give me this as feedback. It's quite fast, but remember, you should always use Practical Lecture 3.1 alongside your assignment 1, right? You do it yourself. You will go back, look at things, the recordings, go back, do it yourself. You maybe can even play with some things. We will see later with some parameters. But what we do now is we actually load a training set, right? We don't think about a test set. As you remember from lecture 2, we throw that in the corner. We don't care about this until our model is trained, and we then want to evaluate. And this data is already available. That's what I presented here also actively. We looked in the data with some jobs here where you already see the differences, right? Because here it's not any Google Colab, which is running, so to speak, on one resource. We have really 15 cores available. And the job is completed at some point in time. Admittedly, it's not the big data jobs. Now, we would have a terabyte of data to do this, more jobs would be spawned to leverage this kind of different cores. Then we want to look a little bit more to the data. We call that feature selection, right? Also remember again, the CRISP-DM, we are now in the data preparation, data understanding. We're sort of knowing now violations, okay? So we go further and further in this and understand, okay, there's a fail and pass, 2-class problem, fail and pass. Not hard to understand, but I think very straightforward, right? Now bring back to mathematical building blocks, connecting it a little bit with lecture 2. We had the same idea, if you remember, with our linear perceptron. So, okay, if we have a binary classification problem, we just need to have a line. So a linear learning model differentiating class 1 from the other would be maybe enough. We don't need cutting edge deep learning. We don't need SVMs, maybe. Let's go for this. But we also know there's no mathematical formula, right? So the target function is not existing. We have to, let's say, in one respect, approximate it or learn it, right? Which makes a bit difference to statistics, where I can also allude to later on. So you put actually something what we call your kind of tool set, right? So as a machine learner now into the game and say it's a linear learning problem, obviously. So maybe with logistic regression model, not support vector machine, is very sophisticated material, would do the job as well, but maybe it's not really needed. Logistic regression can be still strong for those ones, or even ANNs, so neural networks with lots of hidden layers, would be way overdoing in this simple kind of idea. And whatever we learn out of these functions with the logistic regression and so on, learning this weights, in a way, learning a function, right, with the coefficients, we will come to something which is hopefully G approximating F very well. So by now you have the hypothesis set that could be a support vector machine, could be a logistic regression. It is actually the one we pick as a human to say that is something we want to use. And hopefully then by using this one G that is part of the hypothesis set here, we will approximate F, which was this unknown target function that we never know, and hopefully will do the approximation very well. Hence, let's put that in our diagram to understand that a little bit better. We have some things we now derive from our skill set, which is, okay, we want to have this different hypothesis set. We picked logistic regression, this G, right, this kind of model with some certain very specific parameters that we will learn then with weights, and hopefully after the learning, we have the, F, the target function, approximated very well. Now there's some things missing here. I will come to this obviously in all over the learning process. And if you remember, just as an example, again, very briefly, in lecture 2, we had this already. And in assignment 1, you will also look back to lecture 2. We will repeat the bank scenario we had just to understand that a little better, what machine learning is doing, and also to see the difference between the Google Colab versus the MS Azure HD Insight services. Hence, in a way, that's really the first part I really wanted to show you now, right? We will go now having an understanding later with this idea of Jupyter, then more into the real machine learning problems and so on. But then, of course, think about the cluster that we have now. We have now this interesting clusters used. You always saw the connection a little bit if you move now up, that different jobs have been created. And there were different stages. If you remember the stages that have been in the RDD diagram from the directed acyclic graph. So here what I do is a data frame, show me the first 5, right? Very simple material. So hence I need just one stage, one small job. Now consider, I would say, show me the whole, right? Then there would be much more jobs executed, for instance. Equally, if you would say you take one inspection, of course, this is a very small job to get. Also doesn't take much time if you see duration 3 seconds. But this is scalability now inherently. Here we have 6 executors waiting with 15 cores to say, whatever data there is, I will execute it if needed on all these different executors. And of course, then the idea is, and this is what I wanted to show briefly, here are recommended features. You see that a little bit. Auto scale, automatically increase or decrease the number of worker nodes based on a schedule or specific performance metrics. Hence, this is where this cloud, the elastic cloud in a sense, comes in right now. Basically, maybe some of your employments when you are the CTO doing this, for your companies or for someone else as a consultant, you would configure this and will talk to the people that of course have the check or the credit card at hand and say, well, we are willing to go for 10 worker nodes, right? To increase, if someone of our employees really needs it, that's fine, but we should decrease it, right? Again, think about if 10 worker nodes are working, but are sort of idle, right? Not used. They're still working and having the cluster, busy of providing the Spark environment. Then you basically should scale up and down, where this cloud idea comes from, right? That it will be scaling up, scaling down on needs. And basically all the cloud providers have this auto-scaling, or as some call it more like elastic reduce. You have heard it from AWS in the last lecture. It's the same principle. That's where the cloud phenomenon basically came to rise, right? That this cloud term comes. You can actually, shrink the cloud, you can increase the cloud, you can have more services in the cloud, put some lightning in. And this is also what's of course happening here. You can have much more ideas how to use it. You can have a look on Yarn, what is the really usage of the cluster now, using all the different kind of executions. Good. Still, I think, I hope everybody of you got the notion now of understanding that this kind of PySpark environment is sort of really important for us, because it's creating the context, the Spark context with a session that gives us a handle or a grip to the scheduler, right? As one of the graphics suggesting, this is all interconnected. Once you have Spark, and this is a helper function, right? So it's not really a big thing. It just starts here when we use inspections. We always go from Spark then and to do something. So here we'll just load the data in the data frame, but we will later use then Spark underneath to always map the connection that there is a running environment underneath that you see with the different job names and also the different job statuses and so on. But we break here for 10 minutes and then we continue basically after 10 minutes